Okay, I am ready. So it says, what number must be added to both the numerator and the denominator of 3 over 17 to produce a fraction equivalent to 3/5? So what's happening here? We are taking 3 over 17, and they're saying what number must be added to both the numerator and the denominator. Is it the same number that's being added to both? Yes. So we don't know what that number is, so we're going to represent it with x. So I'm going to say plus x in the numerator, plus x in the denominator. And that's going to produce a fraction that's equivalent to 3 over 5. So now we go ahead and we solve this. Is this a proportion? Yeah, what do we do with proportions? What are we allowed to do? Cross multiply them. So I'm going to do my cross multiplication here. So we're going to have 5 times the quantity of 3 plus x is equal to 3 times the quantity of 17 plus x. But Anthony, if you're doing it on the whiteboard, then you won't have notes.
I'm going to take pictures.
You're going to take pictures? Okay. So now we're going to distribute it in. So we're going to have 15 plus 5x. And now distribute this in. We're going to have 51 plus 3x. And now all we do is solve. We're going to get 2x is equal to 36, so x will equal 18. So this is telling us as 18 is added to the numerator and the denominator, it will be the equivalent of a fraction that is 3 over 5. All right, let's keep going. Number 2, if the average speed of a train was increased 10 miles per hour, the 300-mile trip it takes would require 1 hour less in time. Find the new speed. So we have the original speed, and we have the increased speed. Oops, that's not up there, sorry. Hey, if the average speed of a train was increased 10 miles per hour, the 300-mile trip it would take would require 1 hour less time. So again, we're dealing with our distance, our rate, and our time. And remember, our time is our distance over the rate. So for both of these, the original and the increased, do we all agree that our distance is still 300? So distance is 300 for the original, distance is 300 for the increased. If the average speed of the train was increased, do we know the original speed of the train? No, we do not know the original speed of the train, but we do know that whatever that was then increased by 10. So for the increased, it's x plus 10. Now, where does that whole 1 hour less come in? Does it come into the chart or does it come in after in our equation? It comes in after in our equation. That 1 less hour comes after when we're setting up our equation. So our time for the original is just going to be 300 over x. Our time for our increased is 300 over x plus 10. Now, our original time does not equal our increased time. They're not the same. It makes sense. If you're speeding up, it's not going to take you the same amount of time. So we know our original time is 300 over x. Our increased time is 300 over x plus 10. But now, how do we make them equal? Well, it says it would require 1 hour less in time. So, do we agree right now that the original time is bigger than our increased time? Right? So now to keep these balanced, our original time is a longer amount of time than our increased time. To keep these balanced, and we know they differ by 1 hour, to keep it balanced, where am I going to, or what am I going to do with the 1? Subtract it from where? Good. So we have a choice. Our original time is bigger, so we can subtract the 1 from our original time, or what can we do? Add the 1 to our increased time. Does it matter? No, it does not matter which one you do. So we want to go ahead and we will I'll keep it with a plus instead of having a minus and having to distribute it negative numbers. Right, like we said, we could have subtracted 1 from the left side. It would have been the same. You're going to get the same answer no matter what. Okay, so if we do this, is this a proportion? Can I just cross multiply? No, this is not a proportion. I cannot cross multiply. So what I'm going to do is I'm going to eliminate the denominator. So in order to eliminate the denominator, what must I multiply everything by? X times the quantity of x plus 10. We're going to multiply every single thing by x times the quantity of x plus 10. And when we do this, here the x's cancel. So I'm going to get 300 times the quantity of x plus 10. Here the x plus 10's cancel. So I'll have x times the quantity of 300, just x times 300. And then here we're going to have x times the quantity of x plus 10. Now I'm going to distribute in. So I'm going to have 300x plus 3,000 equals 300x plus x squared plus 10x. What happens with the 300x's? They cancel. Am I going to have to factor? Yes, I have to factor because I have an x squared. So I need to set it equal to 0. So what I'm going to do is I'm going to take x squared plus 10x minus 3,000 is equal to 0. And when we factor this, we're going to get an x plus 60 and x minus 50 equals 0. X equals negative 60, x equals 50. Can we have a rate of negative 60 miles per hour? No, you cannot have a rate of negative 60 miles per hour. So for that reason, what am I doing? Rejecting the negative 60. So find the new speed. X is not the new speed. What is X? Adam?
The old speed.
Good. X was the original speed. So the new speed will be 50 plus 10, which is 60 miles per hour. Can I go on to the next one? So Anthony, if you want, the sideboards are bigger if you want a bigger surface area. It's fine? Okay. All right, number 3. The members of the math team were contributing equally to raise $240 for a trip to Mathland, when 4 members of the club decided to stay home and study for their algebra test. Everyone else had to pay $5 more. How many members were on the team? Okay, so I'm going to let X equal members on the team. Okay, so what happened? So initially they were going to take that $240 and split that $240 evenly between the members of the math team. Do we agree? So what are we going to do? We're going to take the $240 and divide it by X. And this is going to be how much each student was going to pay. Right? The $240, if there were 5 students, it'd be $240 divided by 5. Right? So they were originally going to take the 240 divided by however many students were in the group. But then what happened? 5 of them what? 5, was it 5 of them? No, sorry. 4 of them decided to stay home. So now what are they doing? They're going to take that $240 and they're not dividing it by X anymore. They're going to divide it by X minus 4 members. Did I lose anybody with this? Now, is this amount and this amount the same? No, it's not the same. Which amount is more? The 240 divided by X minus 4. These kids are now paying more money. How much more money are they paying? They are spending $5 more now. But now, in order to keep these equations equal to each other, right, we agree this is more, this is less, right? So to keep this balanced, where am I going to add the 5? To the left side or to the right side? To the left side to keep it balanced. Do you understand our logic with this adding to the left side? If you don't, you stop me and then I'll try a different way to explain it. Is this a proportion? No. So I am not allowed to cross multiply. What am I going to tell you to do? Eliminate the denominator. Eliminate the denominator. How am I going to eliminate the denominator? I'm going to multiply by X times the quantity of X minus 4 everywhere. So here the X's cancel. Not there, sorry. So here we're going to have 5X times the quantity of X minus 4. Then the X's cancel, so we're going to have 240 times the quantity of X minus 4 equals, here the X minus 4 is canceled, so we just have 240X. We're going to distribute in that 5X, so we're going to have 5X squared minus 20X plus 240X minus 960 equals 240X. What happens with the 240X's? They cancel. So now we have 5X squared minus 20X minus 960. What do you think I'm going to tell you to do? Pull out a GCF of 5. So now we're going to have X squared minus 4X minus 192. And bring it up here. So now we factor. So we're going to get an X minus 16 and an X plus 12. And we're going to get X equals 16 or X equals negative 12. Can we have negative 12 members in a club? No, you cannot have negative 12 members in a club, so for that reason, I am rejecting the negative 12. So it was saying how many members were on the team, so you tell me how many members were on the team. 16 members. If I asked how many members went on the trip, what number would that be? 12. Very good. Can I go on to number 4? Yeah? Okay. The sum of two integers is 18, and the sum of their reciprocals is 1/4. Find the integers. A lot of these problems can be solved through a system of equations. I'm telling you right now, if you solve through a system of equations on the test, I will not give you credit. I'll maybe give you 1 point for the answer and take off like 5 other points for not doing it the way I want. So I'm going to say it again. A lot of these problems can be solved through a system of equations. You are not allowed to solve through a system of equations. I want it all in one variable. Okay, with that said, let's look at this one, because I think instinctively everybody would just set up a system. So it says the sum of two integers is 18. So I'm starting here, so I'm going to let x equal first integer. Okay, I'm not going to have y be the second integer, because then that's setting up a system, 2 different variables. We want one variable. Well, if the sum of these two integers is 18, wouldn't 18 minus x be the second integer? Okay, so those are our two integers, and it says the sum of their reciprocals. So if the first integer is x, what's the reciprocal of the first integer? 1 over x. And it's saying their sum, so now I'm going to add. What's the sum, what's the reciprocal of 18 minus x? Wouldn't it be 1 over 18 minus x? So it's saying the sum of their reciprocals is 1/4, so that's going to equal 1/4. What am I going to suggest we do now? Not Angie, somebody else. What am I going to suggest we do now? Sia? Eliminate the denominator. So I'm going to multiply by x times 18 minus x. Oh, sorry, it's not just x times 18 minus x. What am I missing? The 4. 4x times 18 minus x. So here the x's cancel. So I'm left with 4 times the quantity of 18 minus x. Here the 18 minus x cancels, so I'm just left with 4x. And here the 4's cancel, so we're left with x times the quantity of 18 minus x. We're going to distribute in. We're going to get 72 minus 4x plus 4x equals 18x minus x squared. We have the negative 4x and the positive 4x cancels. Am I going to have to factor? Yes. So what I'm going to do, I can't factor with a negative x squared. So I'm going to bring everything on the right side over to the left side. So when I bring everything from the right side over to the left side, I'm going to get x squared minus 18x plus 72. And now we factor. When we factor, we're going to get an x minus 6 and x plus 12. Oh, nope, opposite, right? They're both negatives. X minus 6, x minus 12 equals 0. So x equals 6 and x equals 12. If you plug in both of these, whatever the first integer is, let's say you get 6 for your first integer, you'd get 12 for the second one. Let's say you decided to say 12 is your first integer, then what's your second one? 6. Does it matter? No, it does not matter. So find the integers. So the integers are 6 and 12. All right, so now we're going to get to the more difficult problems. Are we done copying these? Anthony and Sean, you guys seem to be goofing off more than anything else. Okay. A pipe can fill a tank in 4 hours. Pipe A can fill a tank in 4 hours. Pipe B can fill the tank in half the time required for pipe C to empty the tank. When all 3 pipes are open, the tank is filled in 2.4 hours. How long for C to drain the tank? All right, what's going on here? Do we agree that pipe A plus pipe B are working together to fill the tank, Sean? Yeah, exactly. So pipe A and pipe B are working together to fill the tank. What is pipe C doing? Emptying the tank. So we're not going to add C. What are we going to do? Subtract C. And that's going to equal 1 complete job. When all 3 pipes are open, the tank is filled in 2.4 hours. Where's that 2.4 going? In the top. This is their working together. Pipe A can fill a tank in 4 hours, so pipe A's individual time is 4. And pipe B can fill the tank in half the time required for pipe C to empty the drain. I don't want to deal with fractional denominators. So what I'm going to do, if pipe B can fill the tank in half the time of pipe C, that means if I call B X, then pipe C is 2 times pipe B. So that's going to be a 2X. So once again, I want to eliminate the denominator. How do I eliminate the denominator? Multiply everything by 4x. You got it. So these 4's cancel, so I get 2.4x. These x's cancel, plus 2.4 times 4. This is 2, so minus 2 times 0.4 equals 4x. So we have 2.4x plus 9.6 minus 4.8 equals 4x. Combine our like terms, 2.4x plus 4.8 equals 4x. Can we multiply both sides by 10 if we wanted to? Yeah, you can. 24x plus 48 equals 40x. So we subtract the 24, so we're going to get 48 equals 16x, so x will equal 3. So how long for C to drain the tank? How long would it take C to drain the tank? 6 hours. So remember, pipe C was 2x. So pipe C will be 6 hours. You know what, guys? I used to put something like this on, but I'm not even going to confuse you guys. We're going to take that off. You don't need to worry about anything like that. So let's keep going to the last one. All right, last one. There's a lot going on in this last one. A boat whose speed in still water is 20 kilometers per hour, so that's the still water rate, traveled upriver 24 kilometers to still water lake, crossed it to the other side 5 kilometers away, then retracted its route back to the starting point. If the entire trip took 3 hours, what is the speed of the river current? So let's see what's going on here just to get a little visual. So we started here and then we traveled 24 kilometers up the river. And then it said it crossed to the other side 5 kilometers. And then what happened at this point? Didn't they then retrack and go back? So then we're going to do another 5 kilometers across the river, and then what? Down 24. Okay, so this is clearly talking about the distance, rate, time. So I'm setting up my table. So we have up, we have across. The other class got upset when I only put across once, so I'm going to put across twice. And then down. Okay, a boat whose speed in still water is 20 kilometers per hour traveled upriver 24 kilometers. So do we agree we went up 24? And when you're going up the river, is the current helping, like adding to your speed or taking away from your speed? Taking away from the speed. So the boat's speed alone in still water was 20 kilometers per hour. So upstream, the current is going to take away from its speed. And then remember, the time is the distance over the rate. So we are 24 over 20 minus x. All right, then we're going across. When you're going across, is the current adding to your speed, taking away from your speed, or not really doing anything? It's not doing anything to your speed when you're going across, right? Horizontal, still water. All right, so when you're across, it was 5 kilometers per hour. That's how much it went across. And its rate, what is its rate in the still water? 20. And its time is going to be 5 over 20, which is equivalent to 1/4. But then didn't we go across again? So we have 5 over, and then 20, and then 1/4. And now the last row is our down river. So the down river again is 24 kilometers distance. Its rate, now the current is going to be helping its speed. And its time will be 24 over 20 plus x. Now it says, if the entire trip took 3 hours, what column am I working with here? The time. So the entire trip took 3 hours. So what does that mean? It is up time plus across plus down equals 3 hours. Do we agree? So what's our uptime? 24 over 20 minus x. What's our across time? 1/4. But then there's another across time, which is another 1/4, plus our downtime, which is 24 over 20 plus x. That will equal the 3 hours. All right, we are going to multiply by 4 times 20 minus x, 20 plus x. Oh, wait, no. I can simplify this more. What's a fourth plus a fourth? 1/2. A fourth plus a fourth is 1/2. Let's simplify this more so we could have even smaller numbers to deal with. So instead of multiplying by 4 times the quantity of 20 minus x times the quantity of 20 plus x, now I can multiply by 2 times the quantity of 20 minus x times the quantity of 20 plus x. Not that it makes that big of a difference, but it's something. All right, so the 20 minus x's cancel. So now I'm going to have 48 times 20 plus x. Here the 2's cancel. So I'm going to have 20 minus x times a 20 plus x. Here the 20 plus x's cancel. So I'm going to have 48 times 20 minus x equals 6 times 20 minus x, 20 plus x. Okay, so now I'm going to distribute in and start simplifying. So we are going to have 960 plus 48x plus 400 minus x squared plus 960 minus 48x equals 2400 minus 6x squared. The 48x's cancel. Anything else canceling? Nothing else is canceling. So now we're going to have like terms here. So we're going to have 2,320 minus x squared is equal to 2,400 minus 6x squared. I'm going to bring that 6x squared over, so we're going to have 5x squared equals 80. So 5x squared minus 80 equals 0. I'm going to pull out a GCF of 5. X squared minus 16 equals 0. So we are going to get x equals plus or minus 4. But we can't have a rate that's negative, so x is just equal to 4. Find what is the river current. River current is 4 kilometers per hour. All right, we are done here.